Have you ever looked up at the sky and wondered why it appears blue? The answer lies in the fascinating science of light scattering, a concept that combines chemistry and physics to explain how sunlight interacts with Earth's atmosphere. Sunlight, or white light, is actually a combination of all the colors of the visible spectrum: red, orange, yellow, green, blue, indigo, and violet. Each of these colors has a different wavelength, with red having the longest and blue and violet having much shorter wavelengths. When sunlight reaches Earth, it passes through the atmosphere, which is made up of gases like nitrogen and oxygen, as well as dust and water droplets. These tiny particles scatter light in all directions, a phenomenon known as Rayleigh scattering. Rayleigh scattering occurs when light interacts with gas molecules that are much smaller than its wavelength. Because shorter wavelengths, like blue and violet, scatter more than longer wavelengths, like red and yellow, they spread out in all directions. While violet light is actually scattered even more than blue, our eyes are more sensitive to blue light, and some of the violet light is absorbed by the upper atmosphere. As a result, the sky appears blue to us. If Earth's atmosphere had a different composition, or if it were denser or thinner, the sky could appear a completely different color. The color of the sky also changes during sunrise and sunset. At these times, the sun is lower on the horizon, meaning its light has to travel through a much thicker layer of the atmosphere before reaching our eyes. As a result, the shorter wavelength blue and violet light are scattered out of view first, leaving behind the longer wavelength red, orange, and yellow light. This is why sunrises and sunsets often display beautiful shades of red, orange, and pink. You can see a similar effect at home by shining a flashlight through a glass of water mixed with a little milk, which mimics how light scattering works in the sky. Interestingly, the color of the sky is not the same on every planet. On Mars, for example, the thin atmosphere is composed mostly of carbon dioxide and dust, which causes the sky to appear reddish-brown. Meanwhile, Saturn's moon Titan has a thick atmosphere with complex molecules that scatter light differently, making its sky appear hazy orange. If Earth had no atmosphere at all, like the moon, the sky would be completely black because there would be nothing to scatter sunlight. In conclusion, the sky is blue due to the scattering of shorter wavelength blue light by the gases in our atmosphere. During sunrise and sunset, the thicker atmospheric layer scatters away the blue light first, allowing the longer wavelengths of red and orange to dominate the sky. Understanding the chemistry and physics behind this phenomenon not only explains why our sky looks the way it does but also reveals how the same process can create entirely different skies on other planets. The next time you admire a bright blue sky or a stunning sunset, you'll know the science behind the beauty. Does the sky amaze you with its beautiful colors? Comment below.